classes preceding this one, we did majoration, we did arcs,
This call is now being recorded.
we did
This call is now taking notes.
arc, sectors, and segments as well. And then we looked at the length of an arc. We looked at the perimeter of segments. We looked at perimeter of sectors as well. That was in the last class. Only a few persons were there actually when we looked at perimeters of sectors and segments. Only a few persons were there, and we wouldn't blame the others because we actually wasn't supposed to have a class on that day, but I had to call for the class so we could treat the perimeters of segments. Please let me know if you can see my screen. Please give a thumbs up if you can see my screen. All right. Okay. All right. Thank you. Okay. So today we'll try to see how we can round up the topic. We've done the length of arc, length of chords, perimeters of segments, both the major segment and the minor segment. We've also looked at the perimeters of the major sector and the minor sectors as well. So today we are moving to areas of segments and sectors. So here we'll put the topic here, area of segments and sectors. So have area of segments and sectors. Okay. All right, so that's the topic, area of segments and sectors. So for a segment, for a sector rather, the area of a sector is theta over 360 times pi radius square. That's the formula for the area of a sector. Theta over 360 times pi radius square. So it looks somehow a little bit there are a little bit of similarity between the length of an arc. You know, the for the length of an arc, it was theta over 360 times 2 pi r. That was for the length of an arc. But for the area of a sector, the formula is theta over 360 times pi radius square. Remember, the sector would have a major sector, a minor sector, depends on how the question is. So now let's look at how to determine the value for the area of the sector. But then I think we also have to look at the area of a segment. But I think let's look at the area of a sector first, because area of a segment does not have an exact formula. It has to be deduced from the a whole set. So we'll look at that when we get there. So let's just start with the area of a sector being given as theta over 360 times pi radius square. Remember, theta stands for the angle and pi. You already know pi is constant, 3.142. And then the radius is that's the radius of the circle. So let's take this question example. Uh, get a bigger right up. Okay, so let's say example one. Draw this circle. Circle. Okay, so let's say this is a circle as we've always done, and let's say that this here, the dot there is the center of the circle, and have a diameter this, this, that isn't. So this isn't drawn to scale though. It just okay. I think this is better. I have here, let's say 100 degrees. Let's say we have the angle there subtended by the chord at the center of the circle at 100 degrees, and we have a radius of 7 centimeter. So this in this question, you are told to determine the area of the sector. Determine the area of the sector. So let's put here determine the area of the sector. Determine the area of the um, first of the minor sector and to a major sector. So do not forget, remember we've said that the area of the sector is given as theta over 360 times pi radius square, and already know what theta means. Theta would be the angle subtended, and then pi is a constant, 3.142 or 22 over 7, as some of you are very familiar with. Then the radius is 7 centimeters we have here. So that's the formula, theta over 360 times pi radius square. So now we come here and try to substitute what we have. So for the minor sector, area of the minor sector, we do know that the area is theta over 360 times pi radius square. It is always important that you write out the formula you would be using to solve a question. It is very important both for WAEC, GCSE, and the likes, because by your marking scheme, I can't recall if it was in this class I had advised you guys on how your marking scheme actually looks like. But then your marking scheme both for WAEC and the GCSE, for those that are writing either of them, the the mark you score for each question isn't aggregated at the, like, you don't get the mark just by getting an answer correctly. No, the mark you get is actually a summation of the marks that has been accumulated from your working. So your answer is not what gives you the overall mark. It is your working that actually accumulates these marks until you get to your answer. You see, so if your working is correct and then you eventually got the answer wrong, most times you'll still get up to 3/4 of the whole mark that you're expected to have. That is if your working was correct, but you know the steps, you followed the steps, but probably you made a mistake by maybe sometimes some students will say 2 times 3 is 8. So it is assumed that, oh, this student had too much anxiety or was under too much pressure, exam pressure, and that's why they made the mistake. But they are working, they followed the process. It is just these mistakes. They are marked correctly for you guys. So you do not concentrate so much on the answer. Writing this formula alone gives you a mark, probably 1 mark most of the time. This formula, the correct formula you are to use, writing it alone, that is a mark on its own. So please take note for non-calculator, um, you know, a non-calculator paper. Yeah, that's when you have that. But if it's a calculator paper, they probably paper two, like most of the time it's calculator. Non-calculator, you would not be having the mark. It's just the answer. But for paper one, which we call theory here in Nigeria, or paper one, where you would have to be showing your working, please write out the formula before you start writing, just to accumulate marks. Do you guys understand what I'm saying? Do you understand what I'm saying? Okay, all right. Okay, please take note. It's very important. So, like we're saying, for the minor sector, we're taking the first one, the minor sector, and already know that the formula we're using is area is equals to 3 theta over 360 times pi radius squared. Winner, you're asking a question. What is it?
Your voice is not loud.
Oh, my voice isn't. I think that is the loudest. Okay, do not worry. I'll try to increase the tempo then. Okay, so let's look at the area of the minor sector. So remember, when we talked about this, you should already be very familiar with the minor sector and the major sector. You should be familiar with that already. The minor sector, a sector is formed by or bounded by an arc and two radii. A sector is bounded by an arc and two radii. So when you were asked for the minor sector, if you look at this diagram, you can obviously see that from the diagram there, you can obviously see that your minor sector should be this. That is this one at the bottom. This is a minor where you have this as 100 degrees and you have the radius at 7 centimeters. So this is a minor sector. The minor sector is bounded by an arc and two radii for those people that are actually just joining today. So we've talked about this already. Now, next is to substitute these values into what we have here. So area of minor sector, the area is theta, which is 100 over 360 times pi. Pi is 3.142 times radius squared. The radius is 7. So 7 times 7, that's 49. So 7 square, or you can just say 49 if you like. So same thing. So theta over 360 times pi radius square for the minor sector, that's 100 over 360 times 3.142 as pi times the radius square, that's times 7 square, or you can say times 7 times 7. So when you multiply the numerator, divide by 360, what's the final answer? When you multiply the numerator, 100 times 3.142 times 49, that result divide by 360. What's the answer? Lucas, you're welcome. You're coming late today. All right, so
Good
what's
evening,
the
sir.
result? Have you had a good day today?
Yeah,
Okay.
2.8.
Zero. Sorry, can you repeat that?
It's a
Can you
2.8.
32.8? Can someone please confirm that?
yeah, 42.8.
42.8 centimeters square. So since it is area, the unit should be centimeters square. So say 42.8 centimeters square. So this is the area of the minor sector. The minor sector. This is the area of the minor sector. I understand that you're writing maths on the third. Was it on the third? On the third or on the 5th of June. When exactly is the date for WAEC? What is the exact date for maths in WAEC?
On the third, on the third.
On the third. Christine, when are you having maths in GCSE?
The 14th of May.
14th of May. That would be next week. Okay. All right. So this is by the way. So we have the area here, the area of the sector to be of the minor sector actually to be 48 points. Oh, not 48 exactly. You said 0.2. Okay, that was an oversight. So 48.2 centimeters square. Okay, so that's for the area of the minor sector. We already know that the theta we're using, the angle we're using for the minor sector was 100 degrees. Then we now will progress to the major sector. So let's say here, area of major sector. Area of major sector here. Still theta over 360 times pi radius square. But you should know that for the major sector, look at the diagram here. For the major sector would be the one at the top, the bigger one, the bigger sector. That's
Sir,
something like.
please.
Could you repeat the question you
In that
just?
minor sector, is it 48?
You said 48.2
No, it's
centimeters
42,
squared.
it's 42.8.
Oh, I'm sorry. It's an oversight, 42.8. Okay, so I'm sorry about that. So 42.8 actually, so 42.8 centimeters squared. Then for the area of the major sector, we have same theta over 360 times pi radius squared. But now please let me try to draw the illustration here. The major sector is this one at the top here, the major sector, the one at the top. So I'll try to illustrate it here. The major sector would be this, bounded by two radii as usual. So let's say you have this. This isn't drawn to scale. Okay, let's say that this as well. Okay. Now look at this. We only have the radius there. The radius is still 7 because this straight line here would be the radius. So the radius is still 7 centimeter. But we do not have an angle. We do not have an angle for the major sector. We're supposed to have an angle for the major sector. You cannot use this 100 degrees here. You can't use this 100 degrees here. For the major sector, that 100 degrees, obviously, as you can see, belongs to the minor sector. It is the angle subtended at by the chord at the center of the circle, and that belongs to the minor sector. So please don't answer randomly. I would be asking, I would be directing the question to individuals. So when we are now dealing with the major sector, because now we are to find the area of the major sector. We are done with the area of the minor sector. Now we're dealing with the area of the major sector. What is the theta? You can see there that there is no theta yet for the major sector. That's the reflex angle. You can see the reflex angle there. So look at the diagram. What would be theta? That is the angle for the major sector. So let's hear from Melody. Melody, what is theta for the major sector? All right, very good. 260. Justice, I do not know if I can actually relate a question to you yet because I do not know your foundational knowledge on this topic. So I don't know. But would you want to try? Do you think 260 should be the theta for the major sector? Okay, Justice isn't responsive. Golden. Golden. Melody said the theta to be used for the major sector is 260 degrees. Do you think we should agree with that?
Yes.
Okay. Christine, what about you?
Yes, sir.
Okay. Winner, what do you think about this? Should we use 260?
260 correct.
Okay, Justice raised the hand. Justice.
260
Yes, Winner,
correct.
I got that. Justice raised the hand. Justice, what's your question?
Yes, I do understand.
Yes, I thought so too.
I do
I
not.
thought so too. You might not understand what we're doing because we've had several classes on this. So I do not need to put you up to speed at this present stage. But just try to follow up first for a while and then you see how. All right. So Lucas, how about you? Do you think we should use 260 as the angle for our major sector?
Yes, sir.
All right. So for our major sector, we would be using an angle of 260 degrees because obviously from this diagram, 100 degrees is for the minor sector. And then we have to look for the other and the angle that the major sector would be subtending. And that would be 260 because the sum of angles meeting at the point, those two angles are the center. The addition of the 100 and the reflex angle should be 360. So that means we're using 260 for our major sector. So we say 260 over 360 times pi, which is 3, and pi is 3.142, 3.142 times radius squared. So you can simply say 7 squared, because that's radius squared, 7 squared. All right, so someone please help us with this. Multiply the numerator, divide by 360. Multiply the numerator, divide by 360. What's the result?
111.19.
Okay, so we have 119.19. That's
No,
119.2.
she said 111.19.
111. 111.
111.19.
Okay. 0.19. That's 111.2 centimeters squared to one decimal place. If we're approximating to one decimal place, 111.19. That's 111.2 centimeters squared. to 1 decimal place. Please take note the correct units. If you're looking for length, you say your answer should be in centimeter. That's when you're looking for length. If you're looking for the area, which you have to use its formula, please take notes and be sure that your answer is in the correct unit. So centimeter squared, that's the unit for area. Since this is measured in centimeter, so you say centimeter squared. If it is measured in meter, you say meter squared. So this is how you find the area of a sector. This is how you find the area of a sector. You can see it here that the area is given as theta over 360 times pi radius squared. So this is what you do basically. And then then you have the major and the minor, which we just did here. Then there's also the area of a segment, but a segment doesn't actually have a particular formula for the area. So the segment has some kind of should I say a derived formula for the area of a segment. I'll try to show you what I'm attempting to say actually by a derived segment. So let us take another question. I think we should just try to copy this same stuff we did here. Okay, I'll just draw another one. So let's call this example 3. Now I want to look at how to determine the area of a segment, which we don't have a direct formula to. So we'll just see how this is done. Christine, most of your questions are not, you said you're writing Ed so most of your questions are not actually like in this context as regards this particular topic we're dealing with. If you have a question in this topic, you might just be asked the shallow part of it. Yeah, that's the BCS. You might just be asked the shallow part of it if a question comes from this particular topic. So it is for these, mostly for these the YX students. They are the ones that has to work out most of these things. The ADSL, most times you just have just a shallow part of it. So I think if you have any challenge, let us know. But then it's your own part is just the shallow part of it actually, because I have taught so many of people that are sitting for the GCSE. So I know the
Please,
pattern of questions you are to ask. I know the pattern of questions you are to.
sir,
Yes, are you going to say something?
please, how do you get that 111.2 centimeter?
I asked you to multiply the numerator divided by 360, and then the result that came was 111.2 centimeters squared. Isn't that correct? Have you done it? What was the result you got?
I've seen it.
Okay, you've seen it. All right. So let's look at how to determine the area of a sector, of a segment rather. What we just did is the area of a sector. So let's move to a segment, area of segments. So we'll take this. So All right, so let's say we have this here, and then at the center we have the center there, a chord which is not a diameter. This, then now you're now given this bottom would be shaded. You see that bottom there shaded. So let's say this is at this top we have 60 degrees. 60 degrees. What should we use here? 5 centimeters. Then the question is to find the area of the shaded portion, or determine. This is the word determine the area of the shaded portion. Determine the area of the shaded portion. The question. All right. To determine the area of the shaded portion, look at that shaded portion. Yeah, look at the shaded portion. What do you call that shaded portion? Let me ask individually. Look at it very well. That shaded portion in this diagram now. What do you call that shaded portion? So let me ask individually. Matilda, you're in the class. You didn't join the class early. Matilda, what do you call this shaded portion in this diagram?
Good evening, sir. I'm not too feeling strong. That's why I did not join early. I can ask a question for now. I'm just looking at the screen.
Okay, all right, that's fine. Okay, so who else? Let's say, let me look for someone else. Melody, what do you call Melody? What do you call this shaded portion? We're asked to determine the area of the shaded portion. What is the name for this shaded portion?
So I'm not seeing your screen now.
You can't see the screen. Oh, it could be your network. Just disengage and join the class again. Disengage and rejoin. Golden, can you see the screen? Oh, Golden left. Golden left. Melody. Melody, can you see the screen now? Not responsive. Lucas, can you see the screen?
2 centimeter.
Yes,
Okay, what is the name for this shaded portion that we're being asked to determine?
Is that not the minor sector?
Sector. Who answers that? Who was asking if it was a minor sector?
Matilda. Yeah.
Oh, Matilda. The minor sector, that is not a sector. Remember, a sector is formed by an arc and two radii. So that's not a sector. That shaded part isn't a sector. Winner, winner,
Minor segment.
minor segment,
Sir, it's
exactly.
minor
So,
segment.
yes, thank you very much. So that is a minor segment. That is a segment actually, and it is a minor segment. If you recall from when we started the class, we said a segment is formed by an arc and a chord. An arc and a chord. That's what forms a segment. While a sector is formed, look at the sector here. We looked at a sector here. This is a sector, an arc and two radii. So if you look at the shaded parts here, it is not an arc. It isn't formed by an arc and two radii. It isn't formed by an arc and two radii. Look at it. Look at the sector, arc and two radii at the top. Then look at this shaded part at the bottom. That is a segment. An arc and a chord forms that part that is shaded. So invariably, they are actually asking you to find the area of the minor segment. That's what they're asking you to do. Find the area of the minor segment. So like I have told you, a segment doesn't have a particular like a fundamental formula. Its formula is derived. So that's what I'm trying to show you here, how to derive the formula for a segment, which in this case happens to be the shaded portion. So I'll cut out that sector, the minor sector. I'll cut it out from this particular figure. So I'll cut it out, and then we'll have something like this. When I cut it out, we'll have something like this. Then have this as a shaded part. Here we have 60 degrees. Here we have 5 centimeters. All right, so now what I just did here is that I have cut out the minor sector. That whole part at the bottom, I cut it out to try to illustrate something. Now look at this minor sector. This minor sector on its own is formed by two distinct shapes. This minor sector, who can look at this intuitively and tell us the two different shapes that forms this minor sector? Who can tell us? Look at this properly, and you see that this your minor sector that we've cut out here is formed by the combination of two different shapes. What and what?
Radius and angle.
No, I'm talking about shapes, not dimensions, not the dimension.
Triangle and semicircle.
Triangle and but not a semicircle. So triangle and something else. The bottom. Triangle and what is at the bottom? At the top is a triangle. At the bottom, it's something. The bottom, a triangle plus something else, two different shapes forms this sector. What and what? The triangle, correct. A semicircle, not correct. It's not a semicircle. Look at it now. It's not coming from, look at this diagram here. That's not a semicircle. Look at where the chord cuts the circle, not from the center of the circle. You can't see that. And what? A triangle and a segment, exactly. A triangle and a segment forms the sector. Originally, if you're looking at the sector as a whole from the circle, the segment is bounded by two radii and an arc. Bounded by two radii and an arc. But when you're talking about shapes, two distinct shapes you can see there in the sector, it is a triangle. There's a triangle at the top, while there is a segment at the bottom, which is a shaded part that you're looking for. This is to say that area of sector is equal to area of triangle plus area of segment. That's to show you that the area of a sector is formed by area of a triangle plus area of a segment, which you can see here as illustrated. Area of sector is equal to area of triangle plus area of segment, because that's what forms it, as you can see. Triangle plus segment. Look at it in the diagram. Triangle at the top, segment at the bottom. So the area of the full shape is a sector. So the area of the full shape sector is equals to area of triangle plus area of segment, which is the one at the bottom. So if you have to get the area of the shaded portion is a segment. The shaded portion is a segment. So if you have to get the area of the shaded portion, you have to find the area of the sector first. You have to find the area of the segment first. Secondly, rather, and then you subtract. To find the area of the segment, which is the shaded portion, you would have to say area of the overall sector minus the triangle at the top. So you have to find the area of the triangle at the top too. And then when you subtract them, it gives you the area of the segment, because the area of the overall sector is a summation of the area of the triangle at the top plus the area of the segment at the bottom to give you the overall area of the sector. So first of all, since a segment doesn't have a fundamental formula, this is what you do. Area of sector, which is overall, equals to area of triangle, the top, plus area of segment, the bottom. So if you're looking for area of the segment, which is the shaded portion, you have to say area of the overall area of the sector minus area of the triangle. So now, first off, let's look for area of this sector, which is the overall sector. So area of sector. The area of the sector is theta over 360 times pi r squared. Theta over 360 times pi r squared. And that our theta is 60, so 60 over 360 times pi, which is 3.142, times r squared, that's 5 to the power of 2. What's the overall answer for area of the sector? Overall result for area of the sector. Area of the sector, what's the overall result?
13.1.
30.09.
30.09. Please someone confirm that area of sector 30.09.
Yes, 13.1.
13 or 30?
13.
Okay, 13.1 centimeters square. So this is the area of the overall sector we have here. Area of the overall sector we have is 5 centimeters squared. 13.1 centimeters squared. This is the area of this overall sector, 13.1 centimeters squared. Now, this sector, like I've said severally, is a summation of the triangle at the top and the segment at the bottom, and we're looking for the area of that segment at the bottom. So if we can get the area of the triangle at the top, then we can simply say, since it is triangle plus segment that gives you the overall sector, then to get the segment at the bottom, we can simply say area of sector minus area of triangle. That's why the formula is derived. Area of sector minus area of triangle. So whatever is remaining is the area of the segment, that's the shaded portion, because the area of the triangle plus the area of the segment has to give you the overall area of the sector, which is 13.1. So now we have to go and look for what is the area of this triangle at the top. Area of the triangle at the top. Now, when you were in, for those of you here in, for those of you in Nigeria, the area of a triangle, when you were in JSS3, you were taught that the area of a triangle is not always half base times height. You were taught the area of a triangle is not always half base times height. When you have the base and the height, that's when you use the area of a triangle as half base times height. That's if you are in JSS3 here in Nigeria. Then for those that would be in diaspora, in year 8 and year 8 and 9, you were also taught that the area of a triangle is not always half, um, what is it called? Half base times height as well. You were also taught that when there is an angle in the triangle, the area of a triangle can be calculated as half AB sine theta. You were taught in JSS3 and also year 9, or year 9 and year 8 and year 9 actually, because I've come across those most of the times, year 8 and year 9. So do you guys recall any such formula as where the area of a triangle is half AB sine theta? Do you recall a formula as such? Please let me know. Okay, winner doesn't recall. Who else? Does anyone recall a formula as the area of a triangle as half AB sine theta when the triangle subtends an angle? When the triangle is having an angle instead of a base and height. Any other person? Just gives if you do not recall anything like that, gives okay, Christine, no. Lucas, no. Matilda, what about you?
Sir, please, what's your question?
I'm asking if do you recall while you were in JSS3 or year 9, depending on where you are, what country you are, do you recall any formula that says the area of a triangle is half AB sine theta? Okay, no, nobody recalls. There is no way you mustn't have been taught. So I do not know what to say about that, but there is no way, because for myself, there is nobody I have taught in the junior high school that I haven't actually taught that. So I think it would be the same for every other teacher. So I don't know, probably you've forgotten, I guess, because we mostly used to have base times height. So I'll try to give a quick illustration. The time is almost up already. If you have a triangle like this, you have the height. Let's say the height is 5 centimeters. You have the base as 3 centimeters. That's when you say area is half base times height, or base times height divided by 2. That's when you do that. What about a situation where you are having a triangle like this? This is how the triangle is. No base, no height. You just have 5 centimeters here as a radius. Maybe here is 3 centimeters, and you have here as 70 degrees, an angle. So you only have the length of the two sides. That the two sides, that's what you call the A and the B. That 3 centimeters is the A, the other side is the B. That's what you call AB. And then you have an angle at the top. If you have any question like this in a triangle, to get the area is half A times B times sine theta. This is a formula. So maybe you can look it up at the end of the class. When an angle, a triangle subtends an angle at the top, or not at the bottom, or at the top, it has to be at the top of the angle. Once you have an angle there, then the formula is half A times B times sine theta. That's what you do. So take note of that. In this case, we have here, you can't use half base times height, because look at this. What you have is an angle there, no base, no height. So to get it, the what is it called? The area of that triangle at the top, you have to use half AB sine theta. So we have A. Some students are like, oh, okay, we have A, but we don't have B. So what then do we do? B is also 5, because have you forgotten that if you look at this diagram, the both sides are radii. The both of them are radii. So if A is 5 centimeters, the other must be 5 centimeters as well, because they are both radii. Both of them, A and B, are radii in this case. Always when it has to do with this mensuration in the triangle, the both sides are always same, because both of them are radiuses. So here, if we come back here, we'll find the area of the triangle now. So for the area of the triangle, we'll be having area of triangle is a half times A times B times sine theta. That's the formula you would be using for the area of the triangle. And that should give 1 over 2 times A. A is 5. We have talked about that. You see it here. A is 5. The other side, B, is still 5, because both of them are radii. So half times A, which is 5, times B, which is same 5, times sine theta. And your theta in this case is 60. You can see it there in the triangle, 60 degrees. The times sine 60. All right, someone please do this. The result of the numerator divide by 2. What's the result? The result of the numerator divide by 2.
Sir, what is the numerator there?
The numerator is 2. That's half times A times B times sine 60. That's half times 5 times 5, which is A times B times sine 60 divided by 2. So what's the result?
10.8.
10.8. So area of triangle is equals to 10.8 centimeters. That's the area of the triangle. Area of triangle is 10.8 centimeters. That's what we have, 10.8. So then next is, now we've gotten the overall area of this sector. We got the overall area as 13.1 centimeters squared. We've gotten the top area of the triangle as 10.8 centimeters squared. Oh, centimeters squared, not centimeter. Okay, the top area of the triangle 10.8 centimeters squared. Then to get that bottom, that shaded part, this is a recurring question, especially for you lots that are writing WAEC. This is a recurring question, very, very important. So for this bottom, to get the value for the bottom, you now have to say overall area of the shape, which is area of the sector, 13.1 minus area of the triangle, 10.8. So what is remaining, whatever is remaining, is the area of the shaded portion. So what is the area of the shaded portion? So what's the area of the shaded portion? What's the area of the shaded portion?
2.3.
2.3. The area of shaded portion is 2.3 centimeters squared. This is it. Area of shaded portion is 2.3 centimeters squared. 2.3 centimeters squared. That is the area of the shaded portion. So this is just what you do. So to get the area of a segment, there's no exact a fundamental formula, but the formula is derived. It is the area of the sector minus area of the triangle at the top, and whatever remains when after you subtract is now the area of the shaded portion. So that's how you get the area of the shaded portion when you're dealing with a segment. So it doesn't have a fundamental formula, but it's derived. Does everybody understand this? Does everybody understand what we just did?
Yes, sir.
Okay, Matilda understands. Who else? Lucas understands. Christine, okay, Christine understands. Justice, oh, Justice, I am sorry. And winner, yes, thank you. You understand. Justice, I am sorry. You actually will struggle to understand what we just did. And we can put you up to speed actually in the class, this particular class, because we've had I think two preceding classes before this. So I am sorry about, there's no way I can put you up to speed actually here in the class, except we'll have to, go back. But you have the videos. If you go on the web here on this platform, just check for the math classes. Take time to watch the videos. I'm sure you would understand what we've done so far. So, but doing that here would almost be impossible because that it's been about two classes at least. So we'll be stopping here for today, and this is the end. Okay, yeah, you're welcome, Justice. So we'll be stopping here for today, and this is the end of this particular topic. This is the end. But then, you guys, um, I have files. I have files. I think Matilda has my number. You could, chat Matilda, or if you don't have access to Matilda, meet Mr. Lotashuku. He will share my number with you. I can share my number with you directly. So meet the admin, talk to Mr. Lotashiko. I have files for like the YGC. You have your past questions in soft copy. The most recurrent questions that you have to deal with, I have them. Meet Mr. Lotashiko or Matilda to you get my number from them. Then for Christine, I don't know if Christine is the only GCSE student. Then I have your files as well. I have your files as well. that I can, send to you, both the paper one, two, and three. You practice these things. You can at any time just, if you have any challenge, any one of you here in the class, if you have any challenge, just send a message. I'm usually very busy. When I see it, when I'm less busy, I always respond and try to, as much as I can, to put you through. So you do not have to wait until you're having a digital class actually. And if you need these files I'm talking about, um, contact Mr. Lotashiku. He'll share you my number and I'll send these files to you because they are recurring questions that you'll be answering in your exams. The best they do is just to change the numbers. Do you guys understand? All right, thank you so much. So we're in the class here. Until next time, do take care of yourself and bye for now.
Thank you,
Bye.
sir.
All right, bye.
Thank you, sir. Good day, sir.
Good evening, sir.